I will take you on a tour to the strangest place you will ever see, which is energy bank. In this place, you will find many particles asking for some energy to exist, depending on special principle, which is called Heisenberg uncertainty principle. If you don't know what's that, then let me explain. This principle states that the shorter time interval, the less precisely we know energy value, and vice versa. Mathematically, it follows this cool relation. Take a look at this piano, which produces energy note instead of ordinary note. And since the player is beginner, so when he's focusing on the accurate timing, the energy note will be less precise. That's the Quantum March Symphony. It's always played by a beginner pianist. But here's the vacuum. Zero energy, right? No one can be uncertain about its value. But you say that nature is like a beginner pianist, always a little off. So energy value cannot be perfectly certain. Exactly. That's why physicists discover something mind-blowing. Even the vacuum has a tiny uncertain value of energy. Otherwise, this principle would be violated. And this tiny energy can be represented as a virtual particle that pop in and out of existence immediately. It's like the particles borrow energy from that principle in this bank and return it in a tiny time interval. Now, you know how this place works. So, let's dive deeply into the quantum world, where every elementary particle comes from a field that permeates through the whole universe. That means the uncertainty actually happens within the energy of the field itself. In another way, we can say that the energy of the field fluctuates. Therefore, it's also called quantum fluctuation. If it's hard to understand, then go to the supermarket and get a soda drink. The drink represents the field and the bubbles represent the virtual particle. But do they really exist? Now I can't see anything, but I know that there is a bubble because I can feel them. The same as virtual particles. We can't observe them directly like ordinary particles. Like ghost and fairy tale, we can only detect their effect. Like in Casimir effect and the lamp shift, where there is a slight shift in the electron energy levels in a hydrogen atom, due to the effect of quantum fluctuation around it. And it's considered the best mathematical tool to describe the fundamental force, because each force is carried by its own special virtual particle.